OCI, Orange County Inspections, is very glad to be offering the QC QA Professional Seminar, segment number 2. We will review the topics that are covered in this segment. Shielded metal arc welding. This is the most used welding process within the industry. From your local welding booths to major projects, this process has become the most popular. Flux core arc welding. This is truly a remarkable welding process that has single-handedly changed the speed of the welding industry. The headlining feature is the continuous feeding of a flux core electrode. Stud arc welding. This one process is used in more industries worldwide than any other single process, from automotive, railroad, shipbuilding, and of course construction, just to mention a few. Air carbon arc welding. This process was founded in 1948 and has developed into the most popular, important tool used by the weld industry to prepare base metal. Shielded metal arc welding. This process uses an arc between a covered electrode and weld pool to accomplish the fusion of base metal. The welder must steadily feed the covered electrode into the weld pool that creates the weld bead. The covering on the electrode, when melted, evolves into gases that shield the weld pool. Once allowed to cool, the removal of the gases, slag, will expose the finished weld bead. The one disadvantage of this process is the continuous feeding of the electrodes. We will take a better look at this process now. SMAW, or shielded metal arc welding, is also known as stick welding because of the use of the electrode rods. Power sources. There are two types of power sources used for shielded metal arc welding. The first is a static machine that converts the electricity supplied by an electrical power company, and the second is motor generated that uses fuel. We continue with the shielded metal arc welding process by looking at the electrical currents needed. Type of current. SMAW uses either the alternating current AC or direct current DC. This is based largely on the kind of weld to be made and the type of electrode being used. Now, let's cover a few more items to note. Change AC to DC current by the use of a transformer rectifier. DC constant current are the amps. The arc gap controls the volts. The SMAW setup. Here we'll take a look at the basic setup for the SMA process. Starting from right to left in this diagram, you view the power source. It can be either AC or DC. Then notice the two welding leads, one for the stinger and one for the ground clamp. The stinger holds the electrode, and as long as the electrode doesn't touch the workpiece, there will be no arc flash. When the two finally touch, there will be an arc that creates the heat to melt the metals into one. We move into SMAW current polarities, and I have a question for you. If the ground clamp is negative and the stinger is positive, what is reverse polarity? It's when the current flows out the negative side of the power source to the grounding clamp, then returns back to the positive side of the power source through the stinger when the arc is created. Okay then, what is straight polarity? Think opposite. Stinger is negative and ground is positive, with the current flowing from the power source to the stinger back to the power source through the ground clamp. We now will look at a very important part to any successful welding process. That is connecting the ground cable to the workpiece. It should produce a strong connection that attaches easily to the workpiece without any loss of current. Spring-loaded clamp. First is the spring-loaded clamp. Typically, this style of clamp is used for light-duty currents. You will find this style used more than any other throughout the industry. Now for higher currents, the screw clamp is usually used, which provides a good connection without overheating the clamp. We have come to our first study break of this segment. Like we did in the previous segment, stop the video and read the guidelines to SMAW, then complete study questions on SMAW. Again, if any questions arise, just email us at orangecountyinspections@yahoo.com. Once finished, resume the video. Flux core arc welding. We now take a look at the welding process that has changed the speed in which the welding industry does production welding from either the shop or out in the field since the early 1920s. The process is very similar to SMAW's process with a few basic changes. One is the electrode, which has its chemical makeup on the inside and is fed into a weld pool continuously. Plus, the option to run a bare wire electrode with external gases for shielding purposes is also available. Let's review the process better. FCAW is the industry standard abbreviation for the process, or the industry slang name is wire. There are two power sources, and they are the same as with SMAW, either electrical or fuel sources. And the recommended current is direct current, constant voltage, typical. Staying with the power source and current used with flux core arc welding, we just saw that the power process needs direct current, constant voltage. But to achieve this, we need to convert the power source by using a CV adapter. This will be found usually inside the machine that the manufacturer has provided. Now let's look at the amperage of this process. Since we have a continually fed electrode, the rate of the speed in which the wire is fed will dictate the amps. So as the feed rate increases, so are the amps, and the opposite happens when decreased. Here we will see the close relationship between arc voltage and arc length. The appearance, soundness, and properties of the welds using flux core arc welding can be affected by the arc voltage. Too high a voltage usually means too long of an arc, which can result in excessive splatter and wider shaped beads, where too low a voltage is a short arc, which will result in a narrow convex bead and reduced penetration. Okay, let's take a look at the setup you might find in the field with the flux core arc welding process. Starting with the power source, if you look in the background of the picture, you will see the silver portable welding machines down on the ground. Following what you have covered earlier, these are producing direct current, constant voltage. In those welding machines are the CV adapters required for constant voltage. The manufacturer has placed them in the machine during the assembly process in the factory. Now the power cables or leads are bringing power up to the flux core arc welding machine, the black box, that is to the right of our welder. On the face of the flux core box is a knob that controls the speed in which the wire is fed through the welding lead, out the gun in his hand that creates the arc and weld bead. Here's a view of the flux core arc welding machine showing the inner workings. By unclamping the door, it will reveal the wheel of electrode on the right side. Then notice the power source cable connected to the bottom left side. This is important when testing with the amp voltage meter. Then on the outside left of the box is the welding lead connection. Looking at the polarity used with flux core arc welding process, it can be either direct current electropositive or direct current electronegative. Now we look at the electrode extension. What is electrode extension? To keep it simple, it's the unmelted electrode that extends beyond the contact tube of the gun handle. Depending on the electrode manufacturer requirements, the extension could vary from a ½ inch up to 3 1/4 inches long. The thing to remember is that as the extension increases, the voltage decreases, which creates less penetrating for the joining the base metals, and the opposite happens when the extension is decreased. We now see the difference between the travel speed and the wire speed of flux core arc welding process. Travel speed is the rate in which the gun nozzle is moved along the weld joint, and the wire speed is the rate in which the electrode is fed out the gun nozzle, also known as feed rate. We have come to our second study break, and like before, just pause the video and read the welding guide for inner shield. Complete the flux core arc welding study questions, and if any questions arise, just email us at orangecountyinspections@yahoo.com. When finished with the study material, resume the video. Stud arc welding. Stud arc welding is widely recognized by the metalworking industries as an essential tool for many challenging joining operations. The process is used without an electrode and external gas or flux. At times, it uses partially shielding in the form of a ceramic ferrule that surrounds the stud. Then pressure is applied using a special design gun that when sufficient heat is reached at the workpiece, it creates an arc flash of welding. We now take a look at the power source required with stud arc welding process. It will use direct current, and the welding machine is typically like this. This process can use over 2,000 amps at times. This is one reason you need to have an amp voltage meter that can register these high amps, and will be ran in direct current electrode negative. How to check the amps and voltage? For volts, you must look for the certified sticker on the machine. This certifies that the machine gauge is accurate. Remember, the certification date should not be older than 1 year. So then for the amps, check by the welder lead. Use the clamp end of your amp volt meter to get a proper reading. Let's take a closer look at the actual material and process for stud arc welding. This welding process can be used to weld almost anything to base metal. Now with this seminar, we will discuss how this process plays a huge role in the composite construction that is used in the industry. First, composite construction means the entire components needed to build a seismic structure: concrete, steel, wood, etc. working as one to resist earthquake forces. So, with the stud arc welding process, the headed studs are usually required to be type B, and ceramic ferrules are used. The flash. This is a critical topic when dealing with stud arc welding. Here we see the actual flash. It should be a complete 360-degree flash around the base of the stud, and if not, the AWS D1.1 code spells out how to fix. Here we take a unique view of the steps that happen during the stud arc welding process. First window, we see the stud against the workpiece, which has a ceramic ferrule surrounding the stud base. We move to the second window, where we see when the trigger on the gun is pulled, this causes the stud to rise, which causes an arc to be created. In the third window, after a set time of arc, the stud is placed back into the melted workpiece, and with help from the ceramic ferrule, creates the needed flash. And the fourth window shows the full 360-degree flash after the ceramic ferrule is broken away. Okay then, how do you go about testing a headed stud? The AWS D11 covers the technique of testing the flash weld of the stud and base metal by either using a hammer or a pipe to bend the stud to the required test degree. Got a question for you. Is this a pre-qualified process? As per the D11, only if the stud is within a 0 to 15 degree slope of horizontal. We have reached the third study break, and as we have done in the past, first is to pause the video. The second thing is to read the arc stud welding fundamentals, and lastly, complete the stud welding questions. As always, if any questions arise, just email us at orangecountyyinspections@yahoo.com. When finished, resume video. We now will look at this process used for preparation and removing base metal in industries from metal fabrication to mining since 1948. The basic principle with air carbon arc gouging is to remove the molten metal with a jet of compressed air. Starting with the power source, most standard welding power sources can be used for this process, and it will need direct and constant current, is ran with direct current electropositive. Some type of air supply is needed, and this process typically uses a copper-coated electrode. Here we have a diagram on the equipment used for air carbon arc gouging. In the first window, we see the power source and the welding leads coming from the machine to the workpiece and stinger. If you look at the stinger, you will see another cable coming in from the top, and this is the air hose. Now, in the second window, this is a closer look at the stinger. The cables coming in from the right side is both the power lead and air hose. As you move to the left of the stinger, you see the valve that controls the air pressure and lever to release the electrode. Now, looking at a few more items that affect the stinger. Stick out. This is the amount of electrode that is sticking past the end of the stinger, and the rule of thumb is about 7 inches. Direction of travel will always be the way the air is blowing. Here are some items that affect the groove that the process creates in the base metal. The depth of any groove will equal the travel speed by the operator. The width of any groove will equal the diameter of the electrode. And rule of thumb is that the width of the groove is usually 1/8 inch larger than the electrode diameter. We have reached our last study section for this segment. Once again, pause the video, read Fabricators and Erectors Guide to Welding Steel Construction, complete study questions for arc carbon air gouging. Got questions? Just email us at orangecountyyinspections@yahoo.com. Once done, resume video. Well, we have come to the end of this segment, and we hope this has either refreshed the basic welding fundamentals for you or have taught you a few things. We covered the basic equipment and setup, then the proper power sources and polarities, and finally the key points for successful welding of base metals using shielded metal arc welding, flux core arc welding, stud arc welding, and arc carbon air gouging processes. Please move to segment number 3.